Today I'm going to be talking about plotting in Matlab. Just an overview, I'll talk about 2D line plotting, the most simple form of that. I'll then talk about how you can add detail to that line using line specifiers. You can also add detail to the plot itself and the axes using axes and labels functions. I'll look at how you can plot repeatedly in multiple figure windows on the same axis and in subplots. So this is the most basic form of the plot function. It has two arguments. You say plot xy, and this will create a 2D line of vector y versus vector x. So these need to be the same length. Here's an example. So I have this data in a chart. I've got 2010 to 2023, and then I have US employment in thousands. So I'm going to open this code in Matlab. Here it is. I've created my years. So I 2010 to 2023, steps of 1, and then I've copied down these annual employment levels. I have this plot statement, I have my year, which is my X, and my employment Y. And so this is annual employment against year. And so when I run this, I get a little chart, and this makes sense. We have, it doesn't include the 2008 recession, but it increases, and then we see around COVID, it plummets, and then it increases after that. So that's the graph we have. But note that we didn't really get to choose, anything about this line. We didn't choose the color, we didn't choose how the points themselves looked, and so we can use line specifiers to do that. And these allow us to choose a line style, the marker, and the color. So it's close, but now we've added this extra argument, line spec, which is a string specifying the characteristics of the line. So here's just the previous example so we can compare it. We note that Matlab by default chose to use a solid line with a point marker and blue color. So what if we had chose to have this plot statement instead? So everything else, all of our other code was the same, but we had this statement. And I'll open this in Matlab to see what happens. So, this remained the same, and all we did was we changed our plot statement by adding this line specifier, which is RP and a colon. We'll get into what specifically this means later, but when I run it, you see that my line looks different. It's now red with pentagram markers and a dotted line. So this is what I had. Here's up close so you can maybe see it in more detail. And what this meant was R was telling Matlab to use the red color, P said use a pentagram marker, and colon was a dotted line. And on the next slide, I'll show you a chart that, gives you a bunch of these characters and tells you what they correlate to. But something before then to note is that the order of these line specifiers does not matter. I could have written any of these, I could have called the function in any of these ways with this specifier, and they all would have had the same output. So here's that chart I was talking about that tells you what specifier corresponds to, what characteristic of the line. And in Matlab, I want to show you how you can get this chart actually, because it's really useful when plotting functions. I can highlight plot, I can right click, and then I can click open. And Matlab will come over here and it'll open this page, which is essentially the Matlab documentation. And so there's all this information about plot, but what you really want is this chart here, because this tells you what specifier you can use. So say I wanted to make my line blue with a point, or I'll do blue with a circle and a dash dot line. I can go and do that. I can say, I'll make it blue with a circle and a dash dot line. And so then when I run that, I'm given this plot instead. So that's how you can use line specifiers to, add detail to your plots, or at least customize them. So here's just 3 examples I've put on here of, random combinations, but it just sort of shows you the freedom that you have in Matlab to change the color and, markers of your functions or what you plot. So, we've done this, we've changed our function itself, we've customized it a little bit, but when we take the code away, this is still really empty. And there's nothing here to tell us what this is about. If I hadn't told you in the beginning that we were looking at employment, you would have no idea. And so this is where our axes and labels functions can come into play. The first one we'll look at is title, where you can add this title text, a string you put in the function title, and it'll add it to the top of your current axis. You have grid on and off, which are commands that add and remove the grid from the current axis. You have your X and Y label functions, which add this string text to your X and Y labels, or your X and Y axes. You have the text function, which will add at the position XY on your graph the text. And then you have the legend function, which creates a legend on your graph with label for the functions. Note that for the next example, this is sort of redundant, but later on when we plot multiple functions, you'll see how this is more useful. So I'm going to, I actually won't open this one in Matlab, I'll just show you here. This is all the code for creating this. So, this was like the first example. We defined our data in Matlab. Here we plotted it with our line specifier And then down here is where we use those functions. So we created a title, US employment versus year. We see that over here. We turned our grid on. See a grid in the background. We added an X and Y label. So you see both axes are now labeled. And we added some text and a legend. So now when I remove my code, this is a standalone graph. This gives me a lot more information. So that's, good. Here's another example that I'll open in Matlab really quickly, just to show you how, previously we were looking at a case where we had sort of predetermined the data, but here's how you could plot a function if you wanted to in Matlab. So the way I'm going to do this is I'm going to create a vector of my desired x range, and I've chosen my step size. So this is sort of how accurate my line is going to be, and I've chosen to go with a step size of 0.1. I create a corresponding vector of y values by using these operators on my x vector. So now I have a y vector. I plot this, so y against x with that line specifier. So this is going to be a green hexagonal with hexagon markers, unbroken straight line. And then I add more detail to the plot. And so when I run this, I'll continue and step through. So first I get my plot here, green with these line specifiers, and then I can step through all these parts of it, and I'll pull up that thing that you get. And in the end, you're left with this plot. So you have your title that you chose here, plotting a function. You turn the grid on, you have text, wavelength of 2 pi, axes labels, it's all there. And note the legend here isn't very useful because there's only one plot, but later on you'll see that we can add more to this legend when we have multiple plots on this one figure window. So plotting repeatedly. There's three ways we can, there's three ways that are helpful to know in the beginning. We can do multiple figure windows. So we plot each thing in a separate figure window. We can do, a bunch of plots on the same axes, same set of axes, or we can do subplots, which we take a figure window, we divide it, and then we plot in this grid we've created. So looking first at multiple figure windows, we do this using the figure command. And so I have this code here. I'm going to open this in Matlab. So here's multiple figure windows. We have this bit down here, but first we're just going to focus on this. So we've created a vector of our desired x range, so it's going to go from -10 to 10 with a step size of 1. And we've created these vectors of y values, 1 through 4, by performing these operations. So these are essentially, we have 8x, 8x squared, 8x cubed, and 8x to the 4th. We're going to plot the first three. So we say plot y1 against x with these specifiers. Here's the title. Then for the second one, we have this figure command, which tells Matlab, open a new figure window when you plot this next one. For the third, we have to do that again. We say figure, so Matlab will know to create a new figure window when it plots y3. And so then when we run this, and we've stopped before getting down here, so for now we're just looking at this first part, we've created 3 figure windows. I've created 3 figure windows, and I'm actually going to move this to the side. So I have 2, one's back here, and 3's in the back right there. I also have this other part right here where I've written the command figure2, and then I've plotted y4 against x. This hasn't been run yet. I'm going to run it now, and watch what happens to figure window 2. It changed. So what MATLAB did when it saw this was it said figure 2. It went to figure window 2, and it replotted just that one. It left figure window 1 and 3 away, but it deleted the plot that was on figure window 2 and it replotted it. And that's just because I put this 2 here. If that had been figure 1, it would have replotted figure window 1. If it had been 3, it would have replotted 3. If it had just been figure, it would have opened figure window 4. So that's how you can, create new figure windows and plot in them in MATLAB. So here, these 2 figure statements, we opened figure window 2 and 3. And then when we used figure 2, it overwrote that figure window 2 with this new function y4. Now we're going to look at how you can plot repeatedly on the same set of axes with a single plot function. And so I'm going to open this in Matlab really fast. So first we're just looking at this bit here. So we've defined an x range. We have these 2 y vectors we've created by performing these operations on x, and then we've plotted them. But notice how we've plotted it. We've basically have 2 sets of data we want to plot here. We've got y1 against x, and then we do y2 against x. And notice also now legend is a lot more useful because we can label both of our functions, and when we run this, So what MATLAB does is it plots, we have the first one that it plots that blue, then it plots the red, and then this legend aligns these in the same order that we plotted them. Notice that we didn't specify any of the characteristics of these plots, but we can. If I just add my line specifiers here, um, and I rerun this segment of code, we see that, now we have the red diamond line and our blue, I think that's blue hexagon dotted line, and our legend, you know, shows those two. So we can use specifiers. We just add that in. And so if we go back to our thing here, we had this. We didn't use any specifiers, so we just plotted them with its default. We can add specifiers, and it, changes the plot. We can also use hold on and off statements. And so what hold on and off does is these commands set the current axis state to on or off, depending on which one you use. What does this do? Well, let's go back to MATLAB here. So here, this is the same code as before up here. And what we've added now is we've defined this new vector y3, and we've said hold on, we've plotted y3 against x with these specifiers, and we've updated our legend. So when we continue now through that bit of code, our figure window updates to this. And so we see that this green curve was added and the legend was updated with it, but that was because this legend statement. So by saying hold, we tell MATLAB that we want to add this to the figure window, but we want to preserve what was previously there. So MATLAB won't get rid of the past plots, it'll just add this new one to it. So the segment of code added that green plot and we updated the legend. Hold off, I'll show you in MATLAB. Now we have this little bit down here, hold off. So when we do that, we're setting the state of the axes to off, the hold, so it's not going to hold. And then when we run through this, last little bit of code here now, hold off, we've created this new vector y4 and we're plotting it. Figure window 1 is just this new plot. It gets rid of the old figure window and it just replots it. This is what would have happened before had we never turned hold on. So current plots are deleted, y4 is added, and that's this segment of code right there. Now we'll look at subplot. So subplot is a function that with these three arguments, it divides our figure window into a grid of m by n plots, and p specifies the current position. So this is what that looks like. So if we had subplot 2, 2, we have a 2 by 2 divided figure window, and then these positions are read across your rows. So it's 1, 2, 3, 4. If this were a 3 by 3, we'd have 1, 2, 3, 4, 5, 6, and etc. So I'm just going to look at an example of subplot right here. So like with the other examples, we've created our desired x range here with our step size of 0.5. And then we have these subplots here. So what we said is we're going to divide the figure window into a 2 by 2, and then we're going to start at position 1, and we want to plot xx. So essentially this is just a linear line. We're plotting x against x. And so when we run this, we see that first one was x against x. Subplot, the same subplot, so 2, 2. Now we're going to position 2, and we're plotting x squared, then we do x cubed and x4. We've added titles to make it easier to read, but you see how it goes through the positions and plots it. Note that if I were to not change the position and I were to run this, MATLAB isn't going to like fill this spot with anything. It just stays empty. All we did was notice here, this isn't the first degree anymore. Now it's that second degree one that's been filled into that spot instead. So that was a really quick run through plotting in MATLAB. That's what we got there. I'll just note that you can look at MATLAB documentation here to see a lot of other plots. Plot is just one of these little ones here. There's a ton you can do in MATLAB. If this was in person, I'd ask for questions, but it's a video, so thank you for watching.